Friends, in this diagram video series of 12th class physics, I will let you draw the diagrams of the second unit of 12th class physics, that is current electricity. In this series, we will draw the first diagram, that is diagram number 8. We have already drawn 7 diagrams in the unit 1. Now diagram number 8, that is different shapes of Wheatstone bridge. In numericals from current electricity, this Wheatstone bridge is asked in different forms. I will let you know how to draw the diagrams of Wheatstone bridge in different shapes. So what is Wheatstone bridge? Shape number 1, you can see like this. So in a Wheatstone bridge there are basically 5 resistors, 4 resistors like this, and the 5th resistor should be in between this resistance. So if this is P, this is Q, this is R, and this is S. So this 5th resistance you can name anything, you can call it G. So there are 5 resistors in a Wheatstone bridge. This is shape number 1 for Wheatstone bridge. Now we can draw the second shape of Wheatstone bridge. It is asked sometimes in this form also. This is again, you can see there are 4 resistors P, Q, R and S, and the 5th resistor is in between this point and this point. There should not be, the 5th resistor should not be between this point and this point. It should be only between this point and this point like this. So if you want to find the net resistance between this and this, A and B suppose, then the 5th resistor should lie between this point and this point only. Here it is G. This is again the Wheatstone bridge. This is second form of Wheatstone bridge. Sometimes it is asked in the exams in this form also. Now it may be given like this also, like this, in the form of circle. You can draw a Wheatstone bridge. This is also a Wheatstone bridge. Sometimes students confuse. They take this shape in different forms, but actually it is Wheatstone bridge. You can see this is the resistance G, and this is again the Wheatstone bridge. Basically there should be 5 resistors P, Q, R and S, and the 5th resistance should be in between like this. And it may also be in this form also, like this. You can draw. So these are the 5 resistors and 5th one like this. Again you can see P, Q, R and S and this G. So these are the 4 basic forms in which forms this Wheatstone bridge is asked, and one form is also there. Let us see this one. 1 resistance, 2 resistance, 3 resistance. 1 resistance, 2 resistance, 3 resistance, then a resistance over this one, and a resistance below this one. This is also the shape of Wheatstone bridge. If it is P, it is Q, this is R, this is S, and it is G. This shape is most of the times have been asked in the exams. This is the resistance P, this one, and this is Q, this one you can see, this is R, this one, and this is S, this is there, and this middle resistance here it is, this is G. So these are the different shapes, 5 different shapes of Wheatstone bridge which are asked in exams. Now we will see the second diagram, that is, hello friends, now we will learn how to draw the diagram showing the combination of resistances basically in series and parallel. So let us learn them one by one. So first we will draw the resistors in series. So suppose there are 3 resistors, resistance R1, resistance R2. Suppose initially let us take 2 resistance only. Suppose this is the resistance 1 R1 and this is the resistance 2. Okay, so if we connect them like this, then they are said to be in series. So for any 2 resistors to be in series, there should not be any joint between them. There should not be any junction between them. What is a joint? Joint is a point where at least 3 wires meet. So you can take this point as joint. This is the joint or junction. So for a point to be a joint, there should meet at least 3 wires. They can be more than 3, also can be there, like this. So there are 5 wires you can see. So can you call this point a joint? No, it is not a joint because there are only 2 wires. 2 wires only there. They are there only. For a point to be a joint, there should be a junction of minimum number of 3 wires at that point. कम से कम 3 वायर उस पॉइंट पे कनेक्ट होनी चाहिए, तब वो जॉइंट कहलाएगा. तो यहाँ पे 2 ही वायर है, तो आप देख सकते हैं इसको. तो ये जो पॉइंट है ये जॉइंट नहीं है, तो ये वाला पॉइंट जॉइंट है. ओके, सो कोई भी 2 रेजिस्टर्स, any 2 resistors will be in series if there is no joint between them. So can you find any joint between them? There is no joint, so they are in series. We can connect another resistance number 3, So here you can see there is no joint between them also. So there is no joint here, there is no joint here. So all the three resistors are in series combination. So this is the way to draw the series combination. So you can see another form like this. So this is also, so there are certain resistors R1, R2, R3, R4, R5 and R6. You can see these two resistors, they appear parallel, but they are not parallel because you can see there is no joint between them. So R2 and R3 are in series. There is no joint between R3 and R4, so they are also in series. There is no joint between them also, they are in series, they are in series. So all of them are in series, and if we pull them from here and here, from the two ends, and we can stretch this wire straight, so it will become straight, and all the 5 resistors are in series. So this is the way how to draw the, how to connect the resistors in series. Okay, now we'll learn how to connect the resistors in parallel. Suppose we have two resistors. Suppose this is R1 resistance and this is R2 resistance. Actually, I would like to tell you that the resistance is a passive component. This resistor is a passive component, unlike the battery. This cell is a active component. It has a positive terminal and a negative terminal. Your capacitor is also a active component. There is one side is positive plate and other one is negative plate. But this is not the case with a resistor. There is no positive negative, and you can connect it from any side. इधर से भी आप ऐसे connect कर दीजिए. So this resistance is a positive. It has no, you can say, no specific end. Or both the ends are equally good, and you can connect it from any side. So this is a passive component. Okay. So there is no preferable end of this resistance. Both are equally good. So this, either you connect this from this side or this side. There is no positive negative in the resistance. So resistance is a passive component, and this the battery cell and this your capacitor is a active component. So suppose there are two resistors you have and you want to connect them in parallel. So to connect them in parallel, you connect their one side. Suppose at this particular point common. Suppose their one side is, one end is taken as common at this point A, and other end is also common. Suppose at this point B. So if this left end of the two resistors is common at point A and the right end of the two resistors is common at some point B, then these two resistors are said to be connected in parallel. Now you can similarly connect three resistors in parallel. Suppose you have three resistors like this, and if you connect their three left ends as common at some point A and the right ends are also common at point B. So their left end is common. The left end of all the resistors is common at point A and the right end of all the resistors is common at point B. So these three resistors are in parallel combination. This is the way how to draw the parallel resistors in parallel. So there is one particular case you can see sometimes students get confused and they think it difficult. So there are three resistors R1, R2 and R3. And if there is a wire, there is one wire above the resistance like this and another wire below the resistance. So this combination you can see the three resistors R1, R2 and R3. Actually they are in parallel. I will let you know how they are in parallel. You can see, suppose this is the resistance R1 resistance we draw here R1, and the left side of this resistance R1 is connected at point A, and you can see the left side, this right side of this resistance, there is no left right side actually. So this side of this resistance R2 is also connected at point A. The right side of resistance R2 is also connected at point A, and you can see that R1 here, R2 here and R3. Okay, R3, the left side of this R3 is also connected at point A. So the one terminal of all the three resistors is connected at point A, and the other side you can see that this side of this resistance R1 is connected at point B, and this side of this resistance is connected at point B, and you can see this side of this resistance R2 is also connected at point B. So one end of all the resistors is common at point B and one end of all the resistors is common at point A. So you can see that these three resistors are in parallel. So this is the way how to draw the resistors in parallel. Now we will learn to draw the diagram to find the internal resistance of a cell. Okay, this is the cell whose EMF is E suppose and the internal resistance is R. Okay, we want to find out the internal resistance of this cell. Suppose we connect a external resistance capital R here and we connect a key whenever you draw any electrical circuit, you must always connect a key so that you can switch on or off at any time, at desired time. If you want to go somewhere, you can switch off the circuit, okay, so that the EMF of the set, the energy of the cell is not used. So this is the key. You can close, open or close it at any time, desired time. You can connect a voltmeter here. So this is the voltmeter. Now if you close this key, current will start flowing in this circuit. This is the circuit. In this circuit, current will start flowing. And at this stage, when current is flowing, current is being drawn from this cell. This cell is in closed circuit. And in closed circuit, the voltage across the two terminals of this cell is known as TPD, terminal potential difference V, and this is not equal to E. It is something less than E. That is E minus IR. This IR, this much amount of voltage drop takes place inside the cell itself. क्योंकि सेल के अंदर क्या होता है, एक इंटरनल रेजिस्टेंस होता है जिसके कारण कुछ पोटेंशियल ड्रॉप सेल के अंदर ही ड्रॉप हो जाता है. सपोज करो कि बैटरी जो है, सेल जो है, जब इसको सर्किट में करंट प्रोवाइड कर रही है, इन दैट केस some potential drop will take place inside this internal resistance which is present inside this cell. So the voltage across the two terminals of cell will not be equal to E. It will be something less than E. That is V is equal to E minus IR. Now by putting this value of current, you can easily derive the formula for internal resistance of cell.